Hi, I'm Kelsey Brennan-Wessels, and in today's special edition of Earth from Space, we are discussing our planet's polar ice sheets. These ice sheets, located in Greenland and Antarctica, are extremely important for monitoring climate change, and they are so massive that their melting can cause global sea level rise. This is why it is important to monitor their size, and Earth observation satellites provide just the tools to do that. Now, over the years, there have been conflicting results from the different satellite data on exactly how much ice Greenland and Antarctica are losing, but an international team of satellite experts has recently reached an agreement on the amount of ice lost over the past 20 years. Now, to find out more, I have the pleasure of speaking with two of the co-authors and leaders of the study called A Reconciled Estimate of Ice Sheet Mass Balance. With me in the studio is Andrew Shepard from the University of Leeds, and joining us via webcam all the way from California is Eric Ivins of NASA's Jet Propulsion Laboratory. Now, Andrew, I'm going to start off by asking you the question that this study so precisely answers, well, more precisely than ever. How much ice are we losing from these ice sheets? Okay, well, we found that the ice sheets of Antarctica and Greenland together are losing enough ice to raise global sea levels by about 0.6 millimetres each year, and so since the start of the survey from 1992 onwards, that's been about 11 millimetres of global sea level rise. That was a surprising result to us. In Greenland, the amount of ice loss is broadly in line with what we measured before, but in Antarctica, it's probably about half the amount of sea level rise that we had expected. So all in all, it amounts to about 1/5 of global sea level rise over the past 20 years. Okay. Now, Eric, I'm going to direct this next question to you. Over these past 20 years, are we losing the ice at a steady rate?
Overall, we're not losing the ice at a steady rate. Greenland is particularly dramatic if we take a look at what was happening in the 1990s versus what's happened over the last decade. Over the last decade, we've had a 5-fold increase in the rate of ice loss from Greenland. Antarctica is a little bit more nuanced in that we have fairly dramatic differences that are going on, but they're going on a regional scale. When we add up all of those regional differences that are going on regionally, we get a fairly constant rate over the last 20 years, a possible 50% increase over the last decade.
Okay, now Andrew, back to you. Now, of course, prior to this study, there were conflicting results in other ice sheet studies. Why is that?
Well, there are several reasons, mainly because there are 3 different satellite techniques for measuring changes in ice sheets, and the space agencies have launched different ones over different time periods. Some of the techniques started in about 1990 when the first Earth observation satellites were launched. Some of them are newer, and so as people have published their estimates at different times, they've used different satellites and they see slightly different things. But also, we know now the ice sheets have their own weather, and that changes the amount of ice and snow that lands on them each year. And if you only look at one particular year, you can see a time of year when the ice sheet is growing a lot. Another time of the year, it might be losing ice. So we find that you have to measure over very long time periods. 20 years is our study. But we also find that you have to be really precise in using the same time periods from all the different satellites, or else you get big differences.
Okay, and then back to you, Eric. How was this international team able to reconcile these conflicting results?
Basically, one of the ways that we were able to reconcile these results was doing our experiments very precisely. So we took precisely the same region, precisely the same time period, and precisely using 4 different techniques. Having those 4 different techniques in place allowed us to be able to kind of see through what may have been weaknesses with one technique and ameliorate those weaknesses by having the strengths of another technique. So having those 4 basic techniques in place really allowed us to have a powerful view of what's happening with the ice sheets for the last 20 years.
Now, what are the future plans for the study of ice sheet mass balance? Of course, this is a question for both of you, but Andrew, could you start by answering?
Well, what we found is that since satellites have been around, we've been able to look at the ice sheets. They're so large you can't survey them, hope to survey them on foot or even by aeroplane. And the satellites have really transformed our knowledge of what's happening at the Earth's poles. And so it turns out that the best way to measure sea level rise from melting ice is to use these satellites. that's the future. One of the problems we have when we're asked to predict sea level rise in the future is that we really don't have a great deal of certainty. And in the absence of accurate model projections, we can only rely on satellites.
Okay. Eric, is there anything you'd like to add?
Yes, I think that one of the things that Andy remarked about, particularly having this 20-year time period in which to view what's happening with the polar ice sheets, is important to recognize that we'd like to keep the space assets that we currently have flying healthy and replenish them with new space observations by launching new satellites. We'd really like to have 40 years to really look at what's happening with the polar ice caps and how they're melting.
So to Eric and Andrew, thank you so much for joining us today. And to our viewers, if you want to learn more about space and about our planet, you can visit our website at www.esa.int. From the ESA Web TV studios, have a great day.